Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome to PMDC online lecture room. Today we are going to discuss the sixth topic of liquid chapter, that is Vapour Pressure, which is present in chapter number 5 of first year chemistry book. Dear students, the important MCQs and question about board exam of this topic are: the MCQ, that is the latent heat of vaporization of water was appeared in 2017, and the question, that is what are the factors affecting vapor pressure, was appeared in 2016. Dear students, today our lecture consists of introduction of vapor pressure, factors affecting and measurement of vapor pressure, and some important exercise questions, and the last part of our lecture is assignment. So first of all, introduction or definition of vapor pressure. Dear students, the pressure exerted by the vapors in equilibrium with its liquid at a given temperature is called vapor pressure. Dear students, vapor pressure does not depend on the amount of liquid and surface area of the liquid like evaporation. Now explanation of vapor pressure. Dear students, consider a liquid is taken in a closed container as shown in the figure. Some of its molecules evaporate and the vapors accumulates above the surface of the liquid because the vapors cannot go outside of the container. As time passes, the number of vapors increases. At the same time, some vapors collide with each other with the walls of container and also with the liquid surface. So rejoin these vapors molecules and comes down, and this process is known as condensation. Thus in the closed container the two processes, that is evaporation and condensation, continue. After some times rate of evaporation becomes equal to the rate of condensation. Dear students, the stage at which the rate of evaporation becomes equal to the rate of condensation is called dynamic equilibrium, and the pressure exerted by the vapors of liquid at this stage is known as vapor pressure, which can be defined as the pressure exerted by the vapors when the rate of evaporation become equal to the rate of condensation is called vapor pressure. Now factors affecting vapor pressure. Dear students, there are two factors which affect the vapor pressure. Number one, intermolecular attractive forces. Dear students, intermolecular attractive forces has inverse relation with the vapor pressure. Stronger the intermolecular attractive forces among the liquid molecules, lower will be the vapor pressure and vice versa. For example, at 25 degrees centigrade, vapor pressure of water is 24 torr, vapor pressure of ethanol is 50 torr, while vapor pressure of ether is 537 torr. Dear students, the high vapor pressure of ether, that is 537 torr, is due to the presence of weak London dispersion forces among the ether molecule, while the low value of vapor pressure of water, that is 24 millimeter of Hg, is due to presence of strong hydrogen bondings among the water molecules. Now second factor is temperature. Dear students, temperature has direct relation with the vapor pressure because by increasing the temperature of a liquid, rate of evaporation of liquid increases. That's why we can say that temperature has direct relation with the vapor pressure. For example, higher the temperature of a liquid, higher will be the rate of vapor pressure and vice versa. For example, vapor pressure of water at 0 degree centigrade is 4.5 torr. Vapor pressure of water at 25 degree centigrade is 24 torr. Dear students, look at the slide. As we go from top to bottom, the vapor pressure of water increases because temperature of water increases. So at 100 degrees centigrade, the vapor pressure of water becomes 760 torr. So it shows that a liquid can be boiled at any temperature, because we can see that water can be boiled even at 0 degree centigrade if we decrease the external pressure or vapor pressure of water from 760 bar to 4.5 bar. Now, measurement of vapor pressure. Dear students, there are two methods for the measurement of the vapor pressure of a liquid. Number one is barometric method. So first of all, barometer. Dear students, a barometer consists of 100 centimeter long tube and a dish of mercury. So procedure: in a barometric method, 1 meter long glass tube is filled with mercury. Then it is inverted in a dish of mercury. The mercury level falls in the tube until it is stopped by atmospheric pressure. The mercury column is measured, which will be 760 millimeter of Hg at sea level and at 0 degree centigrade, and this pressure is known as atmospheric pressure. Dear students, atmospheric pressure can also be defined as the pressure exerted by the atmospheric air by 76 centimeter long mercury column upon 1 centimeter square area at sea level and at 0 degree centigrade is called 1 atmospheric pressure. Look at the diagram. Dear students, there is a long 100 centimeter glass tube which is filled of mercury, and there is a dish of mercury. So if we want to measure the atmospheric pressure, so we will invert the 100 centimeter long mercury column and the dish of mercury. So the mercury column will comes downward due to its heavy nature and high density. After some times, the mercury column will remain constant. There will be no change in the mercury column. So this is due to the presence of air molecules which are present in the atmosphere, and it applies some force on the surface of the mercury which is present in the mercury dish. So at sea level and at 0 degree centigrade, this will be 760 bar or 76 centimeter or 1 atmospheric pressure. Now measurement of vapor pressure of a liquid with the help of barometric method. Dear students, a small amount of ether is placed at the lower end of the mercury and the tube with the help of a dropper, whose vapor pressure is to be measured. The ether rises above the surface of mercury. Ether will evaporate. The ether's vapors will exert pressure and push the mercury level downward. This fall of mercury level in the tube is measured. It gives the vapor pressure of liquid. For ether, it is 537 millimeter of Hg at 25 degrees centigrade. Dear students, look at the diagram of barometric method. Dear students, a liquid is taken in a dropper and then it is put at the lower end of the 100 centimeter long glass tube. So the liquid will comes to the surface of the mercury and the 100 centimeter long glass tube due to its low density than the mercury. So after some times, the liquid will evaporate and the vapors of liquid exert some pressure upon the surface of the mercury present in the 100 centimeter long glass tube and push downward the mercury column. So the decrease in the mercury column will give the vapor pressure of liquid. For ether, it is 537 millimeter, while for ethanol it will be equal to 50 millimeter, and for water it will be equal to 24 millimeter of Hg. Now second method, that is manometric method. Dear students, this method is used for accurate measurement of vapor pressure of a liquid. Manometer is a U-shaped tube which is connected with a T-shaped tube. Now procedure of this method. The respective liquid is shifted and the flask, the mercury is added in a U-shaped manometer in such a way that its height is equal to in both limbs. In order to remove the dissolved or entrapped air, the flask containing liquid is immersed in a thermostat and is frozen. The frozen liquid is again melted. This process is repeated again and again until all the dissolved air is removed from the liquid. The vapor's pressure is measured at a particular temperature with the difference in mercury height of the manometer. The formula for this is given, that is vapor pressure of liquid is equal to atmospheric pressure plus change in height of the manometer lamp. Dear students, look at the diagram of manometric method. There is a U-shaped tube which is known as manometer, which is connected with a T-shaped tube. The T-shaped tube is also connected with a vacuum pump which is used for the removal of the entrapped or dissolved air and liquid. Dear students, at a given temperature, liquid evaporates and the vapors of the liquid comes toward the manometer and pushes the mercury column at the left limb of manometer, and there will be decrease in the mercury column at left side, while there is increase in the mercury column at the right limb of manometer, which goes against the atmospheric pressure. Dear students, after some times there will be no change in both lengths of the manometer. So after that we can measure the vapor pressure of liquid with the help of this formula, that is vapor pressure of a liquid is equal to atmospheric pressure plus delta H. Dear students, delta H is the change in the mercury column at the left limb of manometer. Now some important exercise questions. Dear students, exercise question number 6. Different liquids have different rates of evaporation even at the same temperature. Why? Reason: according to kinetic molecular theory, the liquid molecules are in state of constant motion. These molecules do not have same kinetic energy. Some have high kinetic energy and some have low kinetic energy. Those molecules which have greater kinetic energy move faster and reach to the surface of the liquid, from where they escape in the form of vapors. Different liquids evaporate at different rate even at same temperature, because different liquids have different intermolecular attractive forces. Thus, liquids having strong intermolecular attractive forces will have low rate of evaporation than those liquids having weak intermolecular attractive forces. For example, rate of evaporation of water is lower than the rate of evaporation of gasoline, because there are weak London dispersion forces among the gasoline molecules, while there are strong hydrogen bonding among the water molecules. Exercise question number 7, that is earthenware vessels keep water cool even in hot summer days. Why? Dear students, reason for this question is, since the earthen pots contain small pores, the water molecules with high kinetic energy evaporate through these pores. The heat required for evaporation is absorbed from the pot or the system. In this way, the water present inside the pot becomes cool. Exercise question number 9, that is a liquid boils at different temperatures at sea level and at mountains. Why? Dear students, reason for this question is, the boiling point of a liquid increases by increasing pressure and decreases by decreasing pressure. For example, at Sawabi means sea level, water boils at 100 degrees centigrade due to 1 atmospheric pressure, while at Murray Hills, water boils at 98 degrees centigrade due to external pressure of 0.921 atmospheric pressure, while at the top of Mount Everest, water boils at 72 degrees centigrade due to 0.425 atmospheric pressure. Thus, in hilly areas, cooking times are longer than plain areas. Now, last part of our lecture is assignment, which consists of 3 questions. So dear students, carefully watch the video lecture and do the assignment. Thank you very much and take care.